Okay, today we're going to talk about factoring the greatest common factor and the difference of two squares. Make sure that you take out a piece of loose leaf paper so that you can take notes if you chose not to print this out. So if you remember, when you factor out a GCF, that means the greatest common factor, we're going to find the largest number and or variables that go into each term. We're going to write that GCF. In the parentheses, we write what we would have left after dividing each term by the GCF. You can check your work by distributing the GCF into the parentheses. So if we look at this, if I wanted to factor this, I know I can take out a 4x. That's my GCF. And if I divide each of the original terms by the 4x, I would be left with x plus 4. So my answer, if I factored, is 4x, x plus 4. Okay, let's try a couple of examples. First one, I have 20x squared plus 15x. First thing, look at the 20 and the 15. The biggest number that goes into both of those is 5. If I look at my letters, my variables, x squared is really xx, and here I just have an x. So the greatest number of x's I can take from each term is 1x. Since I'm taking one away, I'm going to get rid of one of each. So now, if I divide the 20x squared by 5x, my GCF, I'm left with 4 and one of the x's. If I divide the 15x by the 5x, I'm left with 3. So my answer there is 5x, then in parentheses, 4x plus 3. If I look at the second example, first we're going to look at the numbers. I have a 27, a 9, and an 18. The biggest number that goes into each of them is 9. So I'm really dividing each of these by 9. Now if I look at the letters, a squared b to the third means AA, B, B, B. AB squared is really ABB. And the last one is just an A and a B. So if I look at the letters, the most A's I can take out of each of them and be equal is 1. So I'm going to get rid of one in each, and I'm going to write an A here. Then if I look at the B's, I can take one here, one here, one here. So the greatest common factor there is 9AB. If I go back, 27 divided by 9 is 3. If I look at my letters, I have an A and two B's, so that's B squared. Then I'm going to write minus. If I look at the second term, 9 divided by 9 is 1. So I could put a 1 if I want. I don't have to. I took out an A and a B. Up here where I crossed them out, I only have a B. And if I look at the last term, 18 divided by 9 is 2. And I took away both the A and the B, so that is my answer when I factor. Let's try a couple more. First thing, look at your numbers. I've got a 48 and an 8. The biggest number that goes into both of them is 8. If I look at my letters, this, I have 3 X's. Here, I have 4. The most I can take from each one is 3 of them. If I divide the first term by 8x to the third, I'm left with 6. If I divide the second term by 8x to the third, I'm left with 1x. So I'm just going to write an x. That is how we factor. If we look at number 4, again, look at the numbers first. The biggest number that goes into negative 32, 16, and 4 is 4. Look at the letters. I have an x to the 5th, an x squared, and an x. The most I can take from each term is 1. Now I'm going to divide each of these terms by 4x. For the first term, I'm left with negative 8 if I divide the numbers. If I subtract the exponents, it's x to the 4th. If I look at the second term, I divide the numbers, I get a 4. Subtract the exponents, I get a 1. And the last term, be very careful. 4 divided by 4 is 1. You have to put the 1 there. A lot of kids like to get rid of it. You have to keep that because when we double check by distributing, if I don't put the 1 here, this term here ends up disappearing. So that's a quick review of how we factor a GCF. The other type of factoring that we are going to review today is DOTS. DOTS stands for difference of two perfect squares. So D means different. It has to be a subtraction, okay? If it's not a minus sign, it does not factor like this. So we're going to make sure that both terms are perfect square roots. There has to be a minus in between them. You're going to write 2 sets of parentheses, one with a plus, one with a minus. You're going to put the square root of the first term in the first spot of each parentheses, meaning here and here. And we're going to put the square root of the second term in the second spot of each set of parentheses. If you want to check your work, you can multiply. So if I look at the example, the square root of x squared is x. That goes in the front. The square root of 25 is 5. That goes in the back. One of your symbols has to be a plus, and one has to be a minus. It doesn't matter if the first one is the plus or the minus, just as long as you have one of each. So let's look at a few examples. We'll try to make them a little bigger. So if I look at the first one, if it says to factor, I know x squared is a perfect square, and I know that 16 is a perfect square. So I'm going to make 2 sets of parentheses, put a plus in one, a minus in the other. The square root of x squared is x. The square root of 16 is 4. So this factors to x plus 4, x minus 4. If we look at the second one, 25 is a perfect square, and so is a squared. The square root of that is 5a. 100 is a perfect square. b to the 4th is a perfect square. There is a minus here, so I'm going to make 2 sets of parentheses. I put a plus in one, a minus in the other. 5a goes in the front. 10b squared goes in the back. And if I look at the last one, you might notice there's a little star here. This is the most popular DOTS factoring that kids get wrong. Everybody always seems to forget that the square root of 1 is 1. So if I wanted to factor this, again, we put a plus and a minus. The square root of x squared is x. The square root of 1 is 1. Big mental note there. That's one that students always miss. Okay, just to make sure that we fully understand what we're doing, I've got 3 more quick examples to go through. If we look at the first one, it says x squared minus 64y squared. Again, the minus tells me I can factor it. The square root of x squared is x. The square root of 64 is 8y. So if I write out my factors, 1 gets a plus, 1 gets a minus. The x goes in the front, the 8y goes in the back, and we're factored. If we look at number 5, again, I hope this is kind of easy. The square root of 144 is 12. The square root of s squared is s. The square root of 49 is 7. And the square root of t to the 8th. Remember, when we're square rooting even exponents, it only works for even. We cut them in half. So that becomes t to the 4th. So the factors for number 5, we put a plus and a minus. 12s goes in the front. And 7t to the 4th goes in the back. And finally, again, 9 is a perfect square. The square root of 9 is 3. The square root of x squared is x. Please don't forget the square root of 1 equals 1. So this last one here, we put a plus and a minus. 3x goes in the front. please don't forget that 1 is a perfect square. If you have any questions, please email me or write them down, and I will be more than happy to help you.